is produced by gluing 6 millimeter thick sheet of glass onto 50 thick plate of polyurethane. So the question says you have 50 thick polyurethane. So there is a polymer material here. This polymer material has a thickness of 50 millimeter. The thickness of polymer material is 50 millimeter. This is polyurethane. It's a polymer, polyurethane. It's actually a polymer. So we are going to produce a composite. What is the meaning of composite? Composite means it consists, it's a mixture of more than one phase, like like polymer with metal or polymer with ceramics or glass, something like that. So here polyurethane is a polymer. It is glued with a thin layer of, this is the layer, thin layer of, this is the layer as you can see here, thin layer of glass. Just a minute. Just okay, thank you. Yeah, I will check it. Yes, its thickness of the the glass is 6 millimeter. So here the thickness is 6 millimeter. So we are using a composite. Composite means a mixture. What are the mixtures here? We have a polymer plus glass, that is the mixture. How we make it? By gluing. This is the glue. This is the interface, gluing. This is the division, or it is called interface between glass. We have one side glass and we have other side polymer. Can you please mute your microphone? Hamid. Okay, now here we have polymer, glass, etc. Polyurethane is 50 glass is 6 and we have made a composite. Why we use a composite is used for, normally it has a high strength to weight ratio. That's why you can find composites. It's a very advanced field, mixing with metal, with the polymer, metal with ceramics, etc. Because such a kind of materials will have high strength and low weight. Especially you can find aircraft materials. It requires high strength and but less weight, etc. Now here we are going to test whether this glue, you glued it, correct? You are not sure whether this joint is perfect or not. You glued glass with the polyurethane and you are not sure whether there is any problem in the joint one. And also you don't know whether there is any crack, any defect present in it. So you are using ultrasonic testing system, ultrasonic inspection, pulse inspection for that. So here the glass probe is used here. This is the probe which is used here on the glass side, and then you will have a couplant here. You know what is couplant? Couplant is like grease, oil, or grease, or something like that, which can remove the air, and ultrasonic waves can pass through it. So ultrasonic waves, without much reflection, it will pass through the glass. So first echo will be from the interface between the crystal. So remember, this is the crystal. So the border or the interface between the crystal and glass, you will receive the first signal. This is the first signal. Remember, from where? From crystal, glass, interface. So after that, the sound waves will hit on the interface between glass and polyurethane. Look at that. Second will be interface between glass and polymer. Glass and polymer, that is this border. And you will get the third signal from where? So first from the front wall between crystal and glass. Second one will be from the interface between glass and polymer. Third will be back wall. What is the meaning of back wall? Back wall means back side of polyurethane. Back wall, we call it as back wall echo. So these echoes we are going to get in this experiment or in this test. As you could see here, crystal. First one will be interface between the crystal and the glass. Second will be between the glass and the polyurethane, this border, as you could see, this border. Third will be from the back wall. This is the back wall. Back wall is here. So question is, if this is a 0, what will be the time for glass polymer and for back wall? Is this question clear to you?
Yes.
Question is
Yes,
clear,
doctor.
right? Yeah, can you try to solve it? I can give you the velocity. It is similar to that the one we studied last time. You know, velocity is equal to distance by time. The same thing, time is equal to distance by velocity. Why 2D? Because it travels 2 times the depth. The sound travels 2 times the depth. That's why 2D by V. So what do you need here? This is the basic equation we are going to use here. What you need here is velocity of polyurethane, velocity of sound through polymer, and the velocity of one more thing you need is velocity of sound through glass. So we know that velocity is constant, but velocity of polymer and velocity of glass will be different. If I get the velocity, it is 6. 5.64 times 10 to the power minus 3 meter per second. Sorry, this is plus 3, not minus 3. This is plus 3. And through poly is 1.96 times 10 to the power 3. Can you calculate now? Can you tell me what are these values? Can you quickly do it and tell me what time you will enter here and what time? So you need to find the first one definitely 0 because between crystal and glass. Then next is back side of the glass. Back side of the glass, or I can say glass polyurethane interface border or back side of the glass. That is second one. We need to find time. Third is backside of the polyurethane. Polyurethane, that is back wall echo. Can you calculate and tell me how much is the time we get here? Is the question clear to you?
Yes, doctor, it's clear.
Yeah, can you calculate and tell me how much is the time you are getting?
Okay.
Just take 5 minutes, try to solve it and tell me how much time you are getting in here.
Doctor, the time will be 2D over V, right?
Yes, yes, yes.
Okay. What D we will take?
D is the thickness or depth or whatever it is. It is the distance.
Okay. Doctor, it will be 1.77 multiplied by 10 power minus 5, right?
Which one?
From glass to bullet.
Glass. Can show you the how much your answer.
Wait, doctor.
I think it is. I think there is a problem in the system. Yes.
Doctor, it will be 2.127 multiplied by 10 minus 6 power.
Raised to minus. Okay. Okay. Then calculate the other one.
Doctor, the another one will be 5.1 multiplied by multiplied by 10 power minus 5.
The last one.
Yeah. No. The last one we have to add, right? So
Yeah.
it will be plus. Doctor, it will be 5.2 multiplied by 10 power minus 5.
5.32 times 10 to the power minus 5, right?
5.2.
I'm getting 5.32.
No problem, doctor. Same.
10 to the power minus
5.
minus 5. Okay. Let us see others. So you got 5.2. Okay. Let us wait for another answer. Anyone is doing, or I can proceed?
Yes, doctor. Wait. Just 1 minute.
I got 5.314.
Yeah, that is right. 5.314 times 10 to the power minus 5, correct?
Yep.
Yes, 5.314. I do something wrong.
So here the first step here is the time taken back side of the glass. So we have here the polymer, then we have a glass here. The glass thickness of the glass is 6 and polymer is 50 millimeter. So we use the equation for time 2d divided by velocity, the speed, 2 times 6 times 10 to the power minus 3 because millimeter to meter. And then velocity we have, velocity is for glass is 5.64. 5.64 times 10 to the power 3, we get the time from the glass. And now we need time from back wall or polymer. This is polymer. So we can say time from polymer is equal to polymer, or polyurethane is equal to what we need to write is the time required from the glass plus the time, right? This is for the composite. I am writing for the composite time coming, or the time required for the ultrasonic waves to reflect from the composite or from the back wall of the composite is equal to time required to travel through glass plus polyurethane. Glass already you calculated it as 0.213 times 10 to the power minus 5 plus. Now here time required for polyurethane. How much is the depth here? 50. So I will write 2 into 50 multiplied by 10 to the power minus 3. This is the distance by speed of sound through polyurethane is 1.96. So 1.96 times 10 to the power 3. So using this, you will get the total time required for ultrasonic to return from backside of the composite. That means ultrasound will strike backside and it returns back to the crystal. That time is called the T composite, which is T glass from glass plus time from polyurethane. So the total time you are getting 5.32 times 10 to the power minus 5 seconds. Is that clear to you? And the first time
Yes,
is 0.213 times 10 to the power minus 5 seconds. If this is clear, then I can proceed to next question.
clear, doctor. Clear.
Any doubt you can ask? So how you are going to sketch it? The sketching, you have to do the sketching, signal sketching. First one, I call it as initial pulse echo. From where? Between the crystal, from here, between the crystal and glass front surface. Second signal will be from back glass side, right? Glass. So I will write it as, or glass polyurethane interface also you can write, both are same. This is 0, then this will be 213 times 10 to the power minus 5. Third will be from here, and that will be from the back wall or from the composite, 5.32 times 10 to the power minus 5. This is called a sketching of the signal. In question, if I ask you sketch, then you have to draw this. Determine and sketch means you have to draw the signal obtained from ultrasonic testing system. Is that clear?
Yes, doctor.
So I can proceed, right?
Yeah.
No more questions. Okay, very good. Now the question here is determine the frequency of ultrasonic waves if the minimum size of the defect to be detected is 0.5 millimeter and the velocity of sound in the material is 500 meter per second. Assess the frequency of the ultrasonic waves if the minimum size of the crack is increased to 1 millimeter. Can you first step read the question at least 3 times before we start? Okay, here in an ultrasonic system, frequency, we need to determine what frequency of testing. Ultrasonic wave, minimum size of the defect is given in the question, minimum size of the defect, which is equal to 0.5 millimeter. Velocity of sound is given as 5,000 meter per second. So velocity of sound is given, minimum size of the defect to be detected is also given. So we have to find frequency. How to find frequency? See, before I go for testing, my aim is defect. Even I should be able to detect a defect which has 0.5 mm size and above. So what frequency I will select for this? So what is the aim or objective? I have to test a specimen. I have to test a specimen. Minimum size of the defect must be 0.5 and above. I should be able to detect 0.5 and above. Velocity of the material is also given 5000 meter per second. So minimum defect condition is equal to lambda by 2. So minimum defect, I will write minimum defect equal to lambda by 2, which is equal to 0.5 millimeter. From this I get lambda equal to 0.5 times 2 millimeter. What is this lambda? Lambda is called wavelength. So if you know lambda, there is an equation connecting lambda, which is the wavelength, with the velocity and frequency. Lambda equal to velocity divided by frequency, correct? So if you know, or V is equal to lambda F. If you know the velocity, if you know lambda, you can find frequency equal to velocity by lambda. Can you calculate frequency? You have velocity and lambda, you will get it from here. Because this is the condition for minimum defect. It has to be minimum lambda by 2. Can you calculate how much is the frequency using this equation and tell me the answer?
It will be 5,000.
5,000. Let me see here.
Same thing, Doctor. Lambda is 1.
Lambda is equal to 1 millimeter, correct?
Yes.
Now velocity is 5,000 meter per second. Lambda is 1 millimeter. So I will convert it into meter. That is very important. Otherwise, answer may go wrong, correct? Yes, Zakaria.
5 million.
Yeah, 5 million. So if you look at it, 5 million. If you look at it, I have multiplied this millimeter. I converted into meter because velocity is in meter. So 5,000 divided by 1 times 10 to the power minus 3, which is 5 times 10 to the power 6 meter. Is it meter? The unit of frequency, hertz. So I can write simply 5 megahertz. This is the answer. Is that right? Megahertz. Is this okay?
Why megahertz, Doctor? H.
What is this?
Yeah, this giga. 10 power 6.
10 to the power 6 is giga. When?
Mega.
Mega, right?
Yeah.
Yes, till yesterday it was mega. Maybe today changed to giga. Okay, this question is clear to you. I can proceed.
Yes, doctor.
Yes, very good. Now the question comes to you. Please do it. Assess the frequency of the ultrasound waves if the minimum size of the crack is increased to 1 mm. So now your aim is you don't need to detect 0.5 mm. I want any material, any defect, say, let me say greater than 1 mm. I just wanted to detect any crack, which is any defect which has greater than 1 mm. I just want to detect. Can you find the new frequency now? Now, if it is 0.5 megahertz, sorry, 0.5 mm, if we want to detect, I should use a frequency of 5 megahertz. This is how we select frequency of ultrasound. This is how we select. We have a minimum size. What is the accuracy we need? Based on that, we select 5 megahertz. Now, question is, if I increase to 1 mm, I need to detect 1 mm and above. What frequency you will select? Can you give an answer for this? Can you calculate?
2.5
2.5.
megahertz.
So V divided by gigahertz or megahertz?
Megahertz.
Megahertz, lambda. So velocity is same 5000. Lambda will be lambda by 2 is 1. So lambda becomes what? See this here. Lambda by 2 becomes 1. Lambda becomes 2 millimeter. So I will write 2 times 10 to the power minus 3. So it becomes 2.5 times 10 to the power 6 or 2.5 megahertz. What is the meaning of it? If you don't need a good accuracy, like you need to detect only higher defects, like more than 1 mm or so, then you need a lower frequency probe. This is 2.5, which is a lower frequency probe compared to 0.55 megahertz, which is a higher frequency. Have you seen it? So depending on the defect size, I can say if you want more accuracy or more sensitive measurement, very small defect, hair cracks, defects need to be detected. You go for high frequency probe. If your accuracy or sensitivity is not that much and you can go for only higher defects, more than 2 millimeter, more than 3 millimeter, then you have to go for lower frequency range. See, this is the difference between the selection. How do we select a particular probe or frequency of a particular probe in ultrasonic testing system? If this is clear, I will proceed to next question.
Clear.
Now we have another question in here. So see, this is the question. An ultrasonic pulse is introduced into 80 millimeter material and a pulse is received by the transducer after 8 times 10 to the power minus 5 seconds. Determine ultrasonic velocity in the material. If this velocity were the result of test using a thin rod, determine the specific modulus of the material. Specific modulus is something related to like a specific modulus. Let me, okay. You have the values given here. Specific modulus can be calculated as simply velocity square, or we write E by rho, elasticity modulus divided by density. So here ultrasonic pulse is introduced into 80 mm thick material. There is a material thickness is 80 millimeter. Now a pulse is received by the transducer after. So we use a crystal. After what time we receive the material, the time is equal to 8 times 10 to the power minus 5 seconds. Determine the velocity of the material. So how do we calculate velocity? You know that distance by time. So we have the distance equal to 80 millimeter, 80 times 10 to the power minus 3 divided by the time is given as 8 times 10 to the power minus 5. So what is the answer you are getting for this? Can you calculate it? How much is the answer? 10 square, 8, 10, 10 cube. I think it has to be 2000, right? Meter per second.
Yes, doctor, 2000.
2000. So here one more zero is there, correct? See, here it is right. 2000 meter per second, right?
Yes,
so
doctor.
It is 2000 meter per second. Now here we need to find a specific modulus. Specific modulus is a property which is called a material property of the material. This material property is calculated by modulus by density. Modulus is constant, density is constant. So this can be written as V square, longitudinal velocity square, because we write V equal to square root of E by rho. So V square will be E by rho. So if you want to calculate specific modulus, just take the square of the velocity, that 2000 square, you will get the answer as 4 multiplied by 10 to the 6 meter square per second square. This is a material property which is specific modulus. So we can calculate that using this equation. Now here, these are the questions we are going to solve today and we'll continue later. But before that, let me ask you something. Yes. Do you remember the date of our exam?
Yes, doctor. 26.
Yes.
26, correct. Absolutely right. Yes. Our exam will be on 26th November and 5 to 6 p.m. Okay. Evening.
Yeah,
This is
yes.
the time for the exam. Now here, before that, I will give you a mock test. This mock test I will open in the coming week, upcoming week, the coming week, maybe during the tutorial, we will do a mock test. Tutorial like any day. When you will be able to do it. For example, we have tutorial sessions on Thursday, we have a lecture even, right? Thursday.
Doctor, if you keep it before the real exam for 2 days, it will be better.
We were asked to do it like because all exams will have mock test and we were asked to do it before we start, like 6th week itself. I will see it, and if that is the case, because 6th week is next week, 7th week is a holiday, and we have exam on Thursday, right? I will see if possible. If there is no such problems, then I can keep it on 7th week. Okay, not 7th, 8th week.
Okay, doctor.
On 8th week.
Because we have been asked to give it in the 6th week. That's why. The mock test has to be given in the 6th week. If it has to be in the 6th week, maybe 6th week last day. When is the last day? 6th week last day. We have Thursday morning, 8 to 9. We can keep it on Thursday morning, 8 to 9. Okay.
Okay, doctor.
That means next week, last day, Thursday, we can keep it. So we will discuss it later, but these are the important things, whatever we studied. So
Doctor,
yes.
this will be module from module